This continues section R3 on page 5. We ended the last video talking about things that were like terms, and I just like to review it because it's very important. Remember, the definition of like terms is they are exactly the same, they have exactly the same variables, and those variables have the same exponents. The easiest way to tell if two or more terms are alike is to cover up their numerical coefficient, the number that's in front of them that is, and see if the rest of what's left is identical. Every single letter that follows would have to be identical in each one. So examples of like terms are in problems 1, 2, and 3 that you see here. If I ask you to add together 3 apples and 2 apples and 4 oranges and 11 oranges, what you would do is group them as I have here, with 3 apples and 2 apples giving us 5 apples, and 4 oranges and 11 oranges giving us 15 oranges. What you did was group things together that were alike. You end up with 5 apples and 15 oranges. There's nothing else that you can do with them. They're apples and they're oranges. They are not alike. So we leave them as two separate terms, so-called, because we can't do anything further and add them any further together. If you cover up the numbers that are in front of them, you have apples all the way down on the one, you have oranges all the way down on the other. You don't have oranges plus oranges gives us oranges to the second power. They stay oranges all the way down. The only thing that changes is the value of the numerical coefficient that's in front of them. If two terms are added together and you cover up those numbers, again, you cannot add them together, just like we have apples and oranges that cannot be added. We're now going to replace the word apple by the letter x, and we're going to replace the word oranges by x to the second power. So instead of 3 apples and 2 apples, we now have 3 x's and 2 x's. Instead of 4 oranges, we now have 4x to the second, and we have 11x to the second. What we do is we group things together that are alike, just like the apples and the oranges. So we group the 3x and the 2x together, and we group the 4x to the second and 11x to the second together. We add the 3 and 2 and get 5. We add the 4 and 11 and get 15. We have essentially 5 x's, or 5 apples, and 15 x to the second, or 15 oranges. We cannot add 5x plus 15x squared together and simplify it anymore. If we were multiplying like we were in the last section, then we could indeed multiply the two of those together, and we would have 75x to the third power. But when we're adding, we have to think of them as apples and oranges. They are not alike because if we cover up the 5 and the 15, they do not look alike because one has x to the first power, one has x to the second power. So this is all we can do, is leave our answer at 5x plus 15x to the second. If you were asked to add 2x plus 3x to the second, it's like apples and oranges above. We cannot add them together. They cannot be combined any further when we're adding, and so we simply end up with 2x plus 3x to the second. That's as simple as we can make that. The textbook on page 18 of the textbook talks about collecting like terms using the distributive property. So what they would do is, if you have 3y to the second plus 5y to the second, they would just use the distributive property to make that 3 plus 5 times the quantity of y to the second. Then add the 3 and 5 together and get 8y to the second. So what they're doing is really taking BA plus CA and factoring out the b plus the c and then multiplying that by the a. We're used to looking at that as AB times, or AB plus AC, and then the a on the left hand side of the grouping of b plus c. But we can do that because the commutative property of multiplication allows us to turn around. They're exactly the same thing. What is not stated in your textbook is that you add like terms together by adding together the numerical coefficients. It's not stated exactly that way in the textbook. They use the distributive property. So in example 1, what the textbook does is, if you have 8x plus 2x, they group together 8 plus 2, which gives us 10x. If you haven't had this before, what I'd recommend is that maybe you write them down in a fashion like you see below, where you have 8x on the top and a positive 2x below it. we add the 8 and 2 together and get 10. So again, if you cover up the 8, 2, and 10, their x's all the way down. When you add like terms together, they're going to stay just the same. That exponent that's on the variable doesn't increase. It would stay just like it was. An example that we saw previously where we said 3x and 7x were like terms, if we add together the numerical coefficients, we get 10x. The textbook would factor out and have 3 plus 7 grouped together times x and adding the 3 and 7 together and get 10x. The other way that might be simpler for you to use it is to write 3x on the top, 7x underneath of it. If you cover up the 3 and the 7, you have x's so they're alike, and add 3 and 7 together and get 10. Again, if you cover up the 3, 7, and 10, the x's are constant all the way down and everything is the same. The next example on 3 was one that we saw previously too. When we add those together, if we just stack them on top of each other, you can see that they all have x, they all have y to the second, and they all have z to the third. So we're simply going to take 2 minus 7, which gives us negative 5, and negative 5 plus negative 5, which gives us negative 10. So our answer for that is going to be negative 10x, y to the second, and z to the third power. In example 4, we have two groupings together, and again if we cover up the 3 and the negative 2, we have x to the second. So we can group that together and make it 3 minus 2, which is 1, or simply x to the second power. The other way that we could write it is one on top of another, where we have 3x to the second minus 2x to the second. 3 minus 2 gives us 1x to the second, or which is just x to the second. On page 9, what I have is 4 problems that I would like you to try to work on your own. You might want to pause the video long enough to try to check these. So there are these 4 problems on page 9. They're worked out for you on page 10, so you can take a look at them and make sure that your answers are correct. Again, what you're looking for here is things that are alike. So on the first one, you have 4 terms. Find the terms that are alike. On the second one, there are 4 terms. Find the ones that match up. On problem number 3, there are actually 6 terms on that one, so line those up that match. Remember, numbers always match whether they're positive or negative. So, for example, on number 4, you're going to end up taking the negative 15 and the 5 and grouping those together. Hopefully those didn't cause you any problem. We're going to go ahead now and do a little bit more addition and talk about subtraction also. The textbook on page 19 of your text states that we subtract something by adding an opposite. Remember, that was how we defined subtraction the first night of class. So here we have a minus b is equal to a plus a negative b. We take the opposite of what's being subtracted, so the opposite of b is a negative b, and add it to the first part. So 5 minus 7 becomes 5 plus negative 7. This is how the textbook tells you to subtract polynomials. We have 2 groupings here, and the group that's being subtracted is the second group. They tell you to take the opposite of that group and add it to the first part. So the opposite of the second group is going to be negative 5, x to the second, y to the third, and a positive 4xy. And we add that to the first. At that point, when it's added, we can just drop the parentheses and add up terms that are the same. The way that I prefer to think of it, however, is by putting a 1 in front of each one of those groupings. From the first night of class, remember the multiplicative identity element 1 says that 1 times anything just gives itself back. So on the first grouping, we can just drop the parentheses because it's a positive 1. On the second grouping, we take negative 1 times the 2 terms that are inside the parentheses, and we get negative 5x to the second, y to the third, and a positive 4xy. Now we have terms, everything is added together, we can match up things that are alike. And the last 3 lines that we see here on this page are the 2 terms that match up. We add together those terms in, so we have 6 minus 5 is 1, and negative 9 plus 4 is negative 5. So on that page, we have 2 different ways that we can write our answer. We can write it with the 1 in front of it or without the 1 in front of it. On the following page, on page 12, I have some addition and subtraction problems for you to try. So remember, if they're connected by a positive, you can just drop the parentheses and add them. if they're connected by a subtraction sign, you have to change everything in the second one and group those together. The answers are on the page that follow this.